In an alternate universe, the arrows of time could run in the opposite direction than we know, unfolding so that our known past exists during the far-off future of a distant world. A pair of scientists from the California Institute of Technology and the Massachusetts Institute of Technology who suggest this concept aren't the first to do so, but they've demonstrated how this phenomenon could arise based on simpler principles than previously examined. Using entropy as the basis for their model, the physicists have developed a way to show the spontaneous appearance of the arrows of time, and how they can flow in opposite directions. In an interview with New Scientist, Sean Carroll of CIT, Pasadena, and Alan Guth of MIT explained that, in the laws of physics, the direction in which time flows does not matter. By this explanation, time which runs backwards would still go in accordance with the laws. While humans have grown accustomed to the idea that events lead to other events in a particular order, Carroll says this is not the case. There's no such thing, at a very deep level, that causes must precede effects, Carroll told New Scientist. In time as we know it, entropy, a measure of disorder, increases. On a universal scale, this means that the future is the direction of time in which entropy increases, New Scientist writes. At a much earlier point in the life of the universe, like at the time of the Big Bang, entropy would be much lower, the researchers explain. In their model, which is not yet published, the researchers drop a fixed amount of particles into an infinite universe. The individual particles each have a randomly assigned velocity, and eventually, arrows of time spontaneously come about, according to New Scientist. Under these conditions, half of the particles will spread outward toward the edges of the cloud, increasing entropy. The other half will move toward the center, decreasing entropy. Once these particles pass through the center, they will continue on, heading outward toward the edge. They're referring to this idea as the two-headed arrow of time. If an arrow of time emerges in one direction, the same will happen in the opposite. Regardless of the starting position, the researchers explain to New Scientist, the particles will all eventually move in the outward direction. The model shows that entropy can grow without limit, indicating that time zero would be the point of lowest entropy. This means that the direction of the individual arrows has no importance, because the cloud will always expand. The point that Alan and I are trying to make is that it's very natural in those circumstances that almost everywhere in the universe you get a noticeable arrow of time, Carroll told New Scientist. Then of course, you do the work of making it realistic, making it look like our universe. That seems to be the hard part. The researchers say this model could apply to all of existence, including the multiverse. But, the model is not perfect, Andreas Albrecht, of the University of California in Davis, explained to New Scientist. They've created a world where they can slip certain notions in very easily, Albrecht told New Scientist, regarding the team's model of the infinite universe, but says he likes the idea of double-headed time. To make a plausible model, the researchers must work to understand the information gaps at the initial state, when the particles are dropped into the infinite cloud, and entropy is both growing and shrinking at the same time. But, they say, the basis of physics on the known understanding of time makes it difficult to determine its behavior under different circumstances.